Hi, everyone. I want to give you the mini lecture on the scientific revolution. And what I want to create for you, the links, intellectually speaking, between the Renaissance, the scientific revolution, and the Enlightenment. They happen in this order, and it's really a logical process. It's a continuity, right? If we go back to the Renaissance, we're talking about the revolution of secularism and humanism combined as Western Europe begins to incorporate all of these pre-Christian Greek and Roman materials, art, literature, science, philosophy, that focus on humanism rather than an explanation for divine intervention. And we saw how that created a whole religious revolution with the Protestant Reformation, that it questioned the authority of the church. Well, it's also going to question the authority of the church in terms of the understanding of the world around us, because if you're already questioning the existence of God as a powerful entity or the church as God's instrument, and subsequently, as you're talking about the challenge of absolutism, once you've questioned the church, questioning the state isn't that far away from it. And then the question becomes, how are you going to prove it? So where the scientific revolution picks up, it actually starts kind of at the same time as the Renaissance. But you've got to remember that with all of this material that was coming in and being introduced to this ready, receptive audience that's looking for answers that aren't based in a religious or supernatural explanation. So as they're starting to take apart, particularly Greek and Roman philosophy, right, they're starting to diffuse all of this information out, and it's going to take a while. And so when you start seeing these challenges to what was understood as the scientific norm in the 15th and 16th and 17th centuries, that's when this is going to start shaking things up. And so it's one more sort of intellectual revolution. As such, once you start questioning, you've questioned the church, you've questioned the state, you've provided an explanation of the natural world, it's really not going to take too long before you make that bridge from investigating the entire cosmos and the universe and the explanation, and then starting to look at the effects of things on Earth, that we begin to bring this down to understand where man's place is in this world. And then it takes this kind of internal shift that becomes political philosophy. That's the Enlightenment, and I'll talk about that in another lecture. Okay, so let me give you this quick overview on the scientific revolution. Let me share the screen for you. So, as I was saying, oops, let me hit play there. As I was saying, it originates with the reintroduction of these thoughts from ancient Greece and Rome, these pre-Christian scientific observations. Now, why that's important and why I'm emphasizing pre-Christian? Because when the church comes in and it takes this biblical interpretation that says God creates the earth in 6 days, rests on the seventh day, and this is the focus of everything as it was meant to be. All right. Well, when you get to the Renaissance and it focuses on humanism and the accomplishments of humankind, right, This is something that goes back to ancient Greece, where they're not relying on an explanation of God created everything. Well, if God didn't create everything, how did it come into being? And so looking for the natural laws and natural explanation of this is one of the driving factors of the scientific revolution. But as I was saying, all of this is reintroduced into Western Europe during the Renaissance, and it's going to take a little while before people start taking apart this material. Humanism, which was still this underlying philosophy, uh, reawakens all sorts of curiosities. And so looking at things from a scientific perspective, which was not unknown, right? I gave you the example in the Age of Exploration about the first century mathematician Ptolemy, who had calculated using trigonometry the circumference of the earth. These ideas are not new. What happens in this intellectual revolution that we're looking at, the scientific revolution, is that they're applied or thought of in new ways. Okay, let's start to take this apart for you. So the scientific revolution, as I was saying, is this next logical outcome stemming from the Renaissance, and it's this through line of intellectual curiosity. So as they begin to look back at these ideas of Aristotle, Galen, Archimedes, Ptolemy, the mathematicians, the scientists who had these ideas, how are we going to frame them in a new context? The availability of these texts is one of the critical factors for the scientific revolution. But here's where we need to sort of break apart the word revolution. That implies something huge. If we think about a political revolution, the American Revolution or the French Revolution, which you'll study next time, it's this massive civil war that's going to change the entire political reality. It involves hundreds of thousands of people. That isn't the case with the scientific revolution. It's a very limited phenomenon, but it's built on collaboratively. That's a second really important factor of this, right? This is an international group of people from all over Europe who are reading these ideas. They're almost like a book club where they're talking about these ideas and how can they prove certain concepts? How are they going to develop the next big ideas and bring these ancient ideas into their worldview? So again, also with the intellectual revolutions of both the scientific revolution and the Enlightenment, these start small. And it's their effects that are going to be massive. But the actual people who carry it out is a fairly small group, okay? So these combined intellectual revolutions, much in the same way that the Reformation had been an religious revolution. And while it's not political at first, once you hit the Enlightenment and it begins to discuss political philosophy, that becomes a whole nother case for you. And then I just wanted to throw in this quick little blurb for you at the bottom, sort of a fun fact, that one particular aspect in the late scientific revolution of the 17th century is that you had a recurrence, an outbreak of the plague, the Black Death. And it struck London particularly hard in 1660s. In 1665, Sir Isaac Newton, who was this phenomenal young scientist, was doing his studies up at Cambridge. But because of the danger of the pandemic, they closed the campus and everybody was supposed to go home. He stayed on campus and continued to do his studies. So the idea of schools shutting down for a pandemic, also not new for you. Also, by the way, he invented calculus while he was on that pandemic break. Yeah. Okay. There is one sort of philosophical step to take or to explain at the start of this, because the idea of the scientific revolution means putting aside most of the religious ideas that you have. That's not universal, and there are going to be a couple of notable exceptions to this, but it takes on the idea of what's called deism. So when we talked about the wars of Europe, and we had talked about some of the political challenges to absolutism, when you get to the Glorious Revolution in Britain that culminates in 1688 with a constitution, right? So just as the Renaissance and the Civil Wars had questioned the church, here's this: how can we put out this idea, the ideas of the scientific revolution, without alienating this really significant, powerful institution, the Catholic Church, in Europe at the time? Deism is this idea. It doesn't take God out of the equation, it just reconfigures the equation, right? So deism argues, of course, there's a creator. Somebody had to create all of this. They call it a prime force, but it's not necessarily the ideas that the church has given us, that there's an all-knowing, all-seeing God Almighty who knows when you're awake, he knows when you're asleep, and he's observing everything you do. In this idea of deism, they say God is like a watchmaker. He created this world, set it in motion, and then has gone off to create other worlds in the same way that a watchmaker builds the watch, winds it up, starts it, and then goes on to build his next watch. It's treading a really fine line with the church. But at this point, as long as they're not saying specifically, well, there is no God and everything just happened because of the Big Bang Theory, and then accretion of dust creates a planet, and da 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 da. They're not even going to say that, because that will get them burned for heresy. However, you have the start of alternate theories of thinking. Also, I just like this cartoon. How did God make the world? So you've got all of his ingredients in a little baking pan from a Gary Larson cartoon. I think maybe he sprinkled too many jerks in this. Anyway, one important thing that is really important in considering the scientific revolution are the approaches to thinking, in the sense of how to approach potentially explosive ideas and explain them in a way that is understandable and doesn't get you on the wrong side of the church. Now, Nicholas Copernicus is one of the first guys to do this. And what he does is look at the traditional understanding of the universe, which is called geocentric, Geocentric, which means that everything is focused on us. We, the earth, is the center of everything, and everything revolves around us. Nicholas Copernicus comes to this, and he's actually spurred on to this by, hang on a second. He's actually spurred on to this by what he was observing as he was trying to, he's actually on a totally different tangent. He's trying to prove that the astronomical year that we live in is not just 365 days in a year. It's 365 and a quarter days. And it's important because if you're not counting that day, that quarter day, at the end of a century, you're off by 25 days. So what Copernicus was really trying to do was to convince the Pope to switch from the Julian calendar established by Julius Caesar and make it more accurate. So in order to do that, he has to prove that there are 365 and a quarter days in the solar year by tracking orbits around the sun. Or in that case, as they were thinking, as the sun orbits around us. But as he was observing, he noticed what appeared to be retrograde motion as he's looking at the motion of the planets around us. And because the planets are at different distances, some travel much slower and some travel much faster. So he was actually looking at Mercury, which is the planet closest to the sun. It's going around faster. So periodically, it looks like, to us from the perspective on Earth, it looks like it's going backwards. And for him, this is kind of what triggers this. Well, wait a minute, what could possibly cause that? Now, the important thing about Copernicus is his approach to this is what we call the what if question. What if geocentrism is not the way things work? What if instead of the Earth being the center of everything and everything revolving around us, what if we're part of a bigger system revolving around the sun? And so he floats out this idea, as you see on the slide, of heliocentrism as opposed to geocentrism, where and in heliocentrism, the sun is the center and we are orbiting around it along with other planets. The important thing is, as he floated out this model and as he begins to write on this in his book on the revolution of heavenly bodies, he is afraid that if he comes out and says this is it, he would be persecuted by the church. So he doesn't come out with it, and he actually waits until he's on his deathbed in 1542 before he publishes it. But once he does, everybody kind of looks at this and goes, wow, that's a really amazing concept. Okay, how are we going to prove it? Here comes our next guy. Yep. Sir Francis Bacon. And for those of you who have done your basic 7th grade science class, you were introduced to scientific methodology, which is setting up a universal standardized method to create a process to investigate. So you come up with a hypothesis, observation, experimentation, conclusion. The important thing in this is, okay, let's not frame old questions in a way that we might be able to reconceive them. Let's ask new questions and figure out how to prove them. But the critical factor here is the idea of empiricism, meaning that it's entirely neutral. Anybody can do this experiment and come up with the same results as long as you are following this standard guideline that he has proposed. So as I said, Copernicus had published the book on the revolution of heavenly bodies, and he drew out this diagram that shows you how you have the sun at the center of it, and then you have this orbit of planets that he arranges concentrically. But because of his what if approach, he never reaches a conclusion, this factor within the scientific methodology. And so this is where you create this collaborative method from across the European courts and universities as people begin to jump in on how they can prove what he's talking about. Tycho Brahe, so he is the court astronomer in Poland, and he begins with the observations of Mars and the orbit of Mars. In case, by the way, you think these are a bunch of dusty old farts who are sitting around thinking great thoughts, Tycho Brahe, you can kind of see in this portrait, his nose is a little funny. Well, he got it cut off in a duel, so this is a prosthesis. He actually has a gold nose that he would strap on in place of where his nose should be. Johannes Kepler comes up with a number of different theories. Um, he, more than almost anybody else, develops math to kind of prove how the inexplicable the lack of matching of orbits, right? Where Brahe was watching the orbits of Mars, where Copernicus had watched the faster orbits of Mercury. He begins to look at this and think about what would account for different time frames in this. And so he comes to the conclusion in his elliptical theory that these are not concentric circles, but it's more of an oval. And so this equation that's at the top with the pink sections on it is his scientific observation of equal time sweeps out equal areas, meaning that if planets are further away, they'll cover the same distance in a longer period of time than something that's closer in, which is going to appear to be moving faster. Okay, and then we get to our big guy, Galileo Galilei. He is an Italian professor of mathematics, but he's, the word for all of these guys is philosophers, lovers of knowledge. They aren't bound by one particular discipline. He is not just a mathematician. Kepler was a mathematician, an astronomer, a physicist. All of these guys are working in different disciplines under the general term scientist. So Galileo comes along almost about 100 years after everybody's been working on Copernicus's ideas on the revolutions of heavenly bodies. And Galileo, takes this step forward. He's invented some new math, he's developed some physics, he improves on a telescope by the use of convex lenses. He begins to write a number of scientific treatises. The first one that he publishes, Starry Messenger, in 1610, looks at the way that the moon and the sun interact to cast shadows. He then switches out to on the letters on sunspots in 1612, which, oh, kids, don't try this at home. He's been sitting with his telescope looking at the sun and trying to figure out what these certain spots and flares would be. Now, part of where he gets into trouble, aside from the fact that he is kind of impatient and he's looking at all of the accumulated knowledge in the last 75, 80 years and wonders, why are we still talking about Copernicus as if this is hypothetical? We've proven heliocentrism. And he tries to explain this in 1613 in a letter to an Italian noblewoman who questions him about how he could use science as an explanation. And so he takes a particular example out of the Bible and breaks it down for her in scientific terms. At that point, the church steps in because they say, you are overstepping your bounds. You want to stay in science, that's on you. However, you don't get to interpret the Bible. And so he ends up, ultimately, it comes, let me go through the next step first. Because he was so annoyed about the church intervening and kind of subordinating all of his work, he wrote in 1632, the Dialogue of the Two Chief Systems of the World. And he sets it up as a conversation between two scientists and kind of the village idiot who just doesn't understand anything. And as the dialogue goes on and develops, it becomes very clear that the idiot in this case is the Pope. So he's really thumbed his nose at their authority, and this gets him brought up on charges of heresy. He ends up getting arrested, and because he's a powerful enough figure, and actually the Pope is a big fan of his work and has somebody reading on the motion of tides was something that was being read to the Pope while he was eating dinner. But once you get to this heresy issue, okay, now that's not funny. So he is under house arrest because he's in very poor health, partly from looking at the sun with his bare eyes, but also he had some pulmonary issues. So he's under house arrest until his death in 1642. However, you've created at this point this international trying to get rid of this here. My screen sharing is paused. There we go. Get back. Sorry. So what you've developed here is this international consortium that's been building on this to come forward and prove what Galileo and Copernicus and Sir Isaac Newton and all of these other guys have developed. How do you prove these thoughts? This again is what everybody's jumping in on. So as I mentioned for you, Newton, who's, man, that guy thought of everything. He's credited with the laws of thermodynamics, that have a really good claim to the development of calculus, so they kind of gave that in itself is kind of a consensus, a collaborative development. But you can see where setting up the world, the galaxy, can be brought down into smaller and smaller components. We're thinking of the vast universe, and then we're thinking of the sun, and we're thinking of the planets, and they go around, and here's the earth, and here's us. And it's not going to take too much longer before you start questioning, where did humans come from, and what is our place in this universe? And that's going to take you to internalized philosophy, and that'll be the next part of the Enlightenment. Okay.